Man.
Hello fellow humans and citizens of the internet, it is I, Spicy Lemon Member 3, and today I'm going to be showing you a way to set up some easy Unity first-person controllers. These controllers can be turned into third-person controllers but are built for first-person, but if you're going to want to turn them into a third-person controller, I will give a tutorial on that later. So without further ado, let's start the tutorial. So the first thing you're going to want to do is go to our channel page and press the button that says GitHub. Basically what this is going to do is bring you to a website called GitHub, and if you don't know already, GitHub is a place where developers all around the world can share their code with other developers. Now while you're on our GitHub, you want to press the Unity First Person Controllers button. It'll bring you to a website where I store my Unity first person controllers, and you're going to want to press code and download a zip. This will download a zip file to your computer that contains all the assets necessary for this project. Once it's downloaded, you're going to want to find the file on your computer, right click it assuming you're on Windows, and extract the file. This will create a new file separate from the zip file. Then you want to drag that file into Unity, and all the assets you need for a project will automatically be imported into Unity. Next up, you'll want to go to that new Unity folder. Find the file called manuel.unity package and double click it. This will open up a Unity UI, and you should just be able to press import all, and now the materials will be in your project. Next, go to the game assets folder that should now be in your Unity project. Select Manuel and drag him into the scene. Manuel is the first person controller that uses the character controller component. He's much easier to use. You can add like slope into him and stuff, but he doesn't use physics, and I like physics, so I don't really like Manuel a lot. So I'm gonna be next to you showing you Jimothy, who uses physics. Go back to the folder where you found all the Unity package files, but this time select Jimothy. Double click Jimothy, press import all, and then go to the game assets folder. Inside the game assets folder, you should be able to find a prefab called Jimothy. Drag him into the scene and just set him up. It's just like that. It's so easy. Jimothy uses physics, which means he uses the built-in Unity physics engines, which I believe right now is NVIDIA Physics, but I'm not quite sure. So I'm going to be going over the code for the physics-based first-person controller. Hopefully I can explain this well. I don't really know. I'm just trying to help you guys explain it a bit better. So basically what we're doing right here is we're creating some variables. First we're creating a reference to our rigid body and our block speed, and then we're getting references to our input. Next we're getting stuff for the camera, so we have camera, mouse rotation, camera Y rotation, a transform for the camera so we can actually move it around. Next we get a float for the sensitivity, which is how much our camera will be multiplied, which is basically like mouse sensitivity. And then look minimum and look maximum, which stop the camera from going too far down or too far up. These next set of variables are to do with crouching and jumping. So basically, as you can see right here, we have a transform for our ground check, which basically allows us to check if the character is grounded. This is important because we don't want our character jumping in midair. Next up we have a boolean for is grounded, which will basically tell our code if the character is grounded, set this to true, and if it's not, set it to false. These are used for physics.checkSphere, which if you don't know, basically puts a little sphere around an object and checks for a layer mask within that sphere. This is that layer mask we're referencing. That is what is the ground, which is why you had to create a separate layer. Next up for these are the crouch height and regular height. And then I don't really know why this is here, I just have it. And then the boolean is crouching will slow you down a bit when you're crouching if you want to. And then ceiling check, make sure that you can uncrouch before you uncrouch. This is walking and sprinting. As you can see, we just have a float for our regular move speed, which is how fast we're constantly moving in character, and then a float for our sprint speed, which is how much we're going to move the character when they're holding shift, which is sprinting. So next up we have counter movement. Counter movement is extremely important when you are making a rigid body controller. This is because rigid bodies tend to be very slippery. And basically what this does is if you're not pressing a key, it applies drag to the object. Default drag is the amount of drag that's being applied when you're pressing keys, which basically allows you to move around freely. But when you release a key, it applies counter drag, which is what slows you down when you release it. If you just don't have any drag, your guy will slip around and it's really bad. This is a vector 2 that stores our movement, and this is a preview movement vector which can tell the difference and also test if our velocity is higher than a certain number. All I'm doing here is setting the rigid body to hopefully get a component of the rigid body. If you don't assign that, sets the cursor visibility to false and locks the cursor in the center of the screen. At the fixed update method, we have movement and jumping and crouching. Basically, what this does is we have a void for movement and a void for jumping and crouching. And these are those booleans I talked about earlier. They check for the ground, and then it basically creates a little sphere around the position, makes it the ground check radius, which is the, radius of the circle, and what is ground, which is the layer mask. And it will basically return a true value if it finds an object with the layer mask what is ground inside ground check radius that is centered around ground check.transform.position. We're using fixed update because when you are dealing with physics in Unity, you always want to use fixed update. This is because if you're messing around with time.timescale, physics can get really weird and really messed up, so it's in your best interest that you use fixed update. Next up, inside our regular update void, we have the get input, which basically gets our input, as you can see right here. X input is input.getAxis horizontal, and this basically returns a 1 or -1 or 0 value depending on which button you press. Same with vertical. Next, camera X and camera Y is just input.getAxis mouse Y times the sensitivity, and this is basically saying get the position of the mouse on the X, get the position of the mouse on the Y, and multiply it by the sensitivity so you can move the camera by that. Down to the camera controls void, we can see that the mouse X rotation is just minus the camera Y. I don't really know why this worked, I kinda had to watch a video on this, but here, we're setting the X rotation of the camera to clamp it at the minimum look and minimum max, so it doesn't look too high or too low. Next up, we're setting the rotation of the camera to transform look rotation and a quaternion that stores X rotation, and then basically 0 is 0 because you don't want to rotate the camera on any other axis. Next up, we have the jumping and crouching void. Basically what this if statement right here is doing, it's checking if it's grounded, and if it is grounded and the input.get button down is jump, which is basically fancy talk for if space is pressed. It's adding force up times jump height times 50, because when you add smaller amounts of force to rigid bodies, it's really not a lot. So I multiply it by 50 so you don't have to enter giant numbers. Next up, we have crouching, which basically says if input.getKeyCode left control, which is, well, basically if you're pressing left control, then it sets your scale to a new vector 1 crouch height 1 and sets its crouching to true. This will basically make your character physically smaller. If it's not, if it can uncrouch, it will set your new height to the regular height. This allows you to not uncrouch if you are, like, for say, under an object. You don't want to uncrouch, but you'll just get stuck in the object, which is not really good. So in the movement void, which is basically what controls the overall movement of the player, we have basically 2 lines of code that are adding force to our rigid body based on the direction that it's facing and the input that's being pressed. So Z input, as I said earlier, is just a float, and this contains the either 1, -1, or 0, which is going to just be a value of whether you're pressing WASD or D or not. Back down here, we can see that we just multiply that by our move speed and transform.forward or transform.right, which moves the rigid body. Next up, we have our counter movement. So basically right here, this is sending the movement vector to the input on our horizontal and the input of our vertical. Next up, we have counter movement, and I would like to thank Always Coding Angry on Unity Answers. I didn't know how to add counter movement, I'm gonna be honest. I kinda looked at some forums, still didn't get it. This man saved my life. Always Coding Angry, if you're watching this video, props go to you. So basically what this is saying is if the preview movement is more than the movement, which basically means we've stopped pressing the key, or the preview movement is less than the movement again, and it's grounded, it applies drag to the rigid body, which is equal to counter drag. If it's not, we just apply the amount of drag that's default drag, which is normally 0, but you could bump that value up. Next up, we have walking and sprinting. This if statement right here is basically checking if the left shift button is pressed down, and it will set the move speed to walk speed. And this basically sets it so if you're pressing shift, you're moving at your walk speed, and if you are not pressing shift, you're moving at your sprint speed.